So in this problem, you're given a pair of expressions to multiply and then to simplify your answer. And what makes this sometimes a bit of a challenging problem is that both of the expressions that we're multiplying together have two terms in them. They're what we call binomials. So they're a polynomial expression in which each of them is the sum or difference of two expressions that can't be simplified any further before we do the multiplication problem. So there's nothing we can do to make this multiplication job simpler. Instead, how did you approach this problem? So how do we multiply these two binomials together and then simplify the answer? Where'd you start? So the first thing that Salim decided to do was to take the first term in the first expression, the 3x, right here, and to multiply that 3x by each of the two terms from the second expression. So that's an application of what we call the distributive property of multiplication, so the multiplication that's happening between these two expressions, across the subtraction or addition that's happening in the second expression. So in a picture, that might look like multiplying the 3x by the 1, as you said, and also multiplying the 3x by the 2x. So to expand this out, what that would look like is that we'll have 3x multiplied by the 1 from the second term. And then we'll also have 3x multiplied by the 2x from the second term. Yeah, so this minus sign in front of the 2x I should carry into the parentheses. So 3x multiplied by the negative 2x from the second term. And then let's go through the process of doing each of those multiplications. What is a quicker way to write 3x times 1? 3x. What about 3x times negative 2x? Yeah. Right, so the coefficient becomes negative 6, 3 times negative 2. And then x times x turns into x squared. So again, remember last week we talked about when do you add exponents in an expression? Because originally my x's each had an exponent of 1. How do we know we need to add those 1s to make a 2? When do you add exponents? When you're multiplying, exactly. Add exponents because we multiplied powers. Okay. Great. So that takes care of the product of the 3x term from the first factor with both of the terms from the second factor. So now what happens with the minus 6? Do the same thing. That minus 6, because it's a part of my first factor, also needs to distribute across the subtraction from the second factor. So, in the same fashion, I'll distribute the negative 6 multiplied by the 1 and the negative 6 multiplied by the negative 2x. If I carry that down, that's going to give me, again, I'm going to write this out in all of its detail, negative 6 times 1 and negative 6 times negative 2x. And I'll simplify each of those. What's negative 6 times 1? Negative 6. What's negative 6 times negative 2x? Positive 12, exactly. The negative times the negative gives me the positive. So I get a positive 12x out of that. Now I'll carry down my 3x, and I'll carry down my minus 6x squared. And now I've done everything I need to do for the multiply phase of this problem. So my multiply step is done. So what do I have left to do? Yeah, simplify by combining like terms. So Jordan, what like terms do you see in this expression that can be combined? 3x and the 12x. How do we know that those are like terms, by the way? Yeah, they both have the same variable factor of x to the power 1, right? They have the same variable, same exponent. The only thing that's different about them is the coefficient, the number that's out in the front. So how do I combine two like terms? What is 3x plus 12x? 15x. Yeah. So I combine by adding the coefficients. And then the last thing I'm going to do is just rewrite it so that my terms are in decreasing order of degree. So I'll put the x squared term first, and I'll put that minus 6 last. And then I've finished. So that's the long way of doing this out. And it's a good practice to do it the long way a few times, so you get a feel for all the different steps that go into this process. Did anybody do the bookkeeping on this differently? Was there sort of a shorter way or ways that you typically remember how to do this process that aren't reflected up here yet? One of the first powerful bookkeeping techniques for multiplying binomials is the technique that we call FOIL. What does FOIL mean? Yeah. So FOIL is this mnemonic that we learn. It's an acronym that tells us how to make sure that we multiply everything that needs to be multiplied before we do the simplify part of it, right? And so it tells us that in order to multiply two binomials, we need to multiply 4 different products. The first pair, so the first term from the first factor multiplied by the first term from the second factor, we call that the F, the first terms in the FOIL. Then the outer terms, the first from the first factor and the second from the second factor, in this case the 3x times the 2x. And then the inner two, the second from the first factor and the first from the second factor. And then the lasts, the second from the first factor multiplied by the second from the second factor. First, outer, inner, and last. And so FOIL helps us remember that we need all 4 of those products to be combined together to give us our finished answer. So FOIL is super powerful. It's also kind of specific to this type of problem. Right? FOIL is really specific in that it only helps us really to multiply 2 terms multiplied by 2 terms, which covers a lot of the multiplying that we do, but not all of it. And when we go forward in our next class to broaden this out a little bit, we're going to talk about a different technique for bookkeeping that I want to at least kind of give you a brief exposure to now, so that we can build on it when we talk about this on Wednesday. And here's how it looks. If any of you have children in the school system lately that are learning math in the fashion of the Common Core state standards, this may seem like a familiar tactic. If you haven't seen it, this might be your introduction to it. I happen to think it's really nifty. It's a way of organizing our calculations in a way that I think is super helpful to make sure that we don't forget anything. So how it works is I'm going to take my 2 factors, 3x minus 6 and 1 minus 2x, and write them as the rows and columns of a little grid. So in this case, I'll put 3x and minus 6 across the top, 1 and minus 2x down the left-hand side of this little grid. And when I set up the grid, I automatically set myself up to see that there's going to be 4 different products that go into this, because in each of these cells, I'm going to place the product of what's on the row with that cell with what's on the column of that cell. You can envision doing this in an Excel spreadsheet if you were so inclined. We're not going to do that, but you could if you wanted to. So for example, in this first cell right here, I would multiply 3x times 1, and I would get, well, what would I get? That's the easy product here. 3x times 1 is going to give me 3x. And then likewise, in the upper right-hand corner, negative 6 times 1, negative 6. Lower left, 3x times negative 2x, negative 6x squared. And lower right, negative 6 times negative 2x, positive 12x. So this little grid, first of all, reminds me how many multiplications I have to do, 4 in this case. And second of all, it gives me a convenient way for organizing all those different products. And so it helps me on that multiply step, not to forget anything, because that's one of the more common errors that you can make in working multiplication of polynomials problems, is forgetting one of the factors, forgetting one of the products, or more, in fact. And then once I have all of these there, how do I then combine them to get my final answer? Yeah, we can just go directly from that chart there to this line in our calculation, right? Just write out all of my terms added together, and then look for the like terms that I can combine. And in this case, I could even spot those like terms within the cells of my chart, 3x here and 12x here, those are my like terms, such that when I combine them together, I got 15x. I like this little grid because that seems like a method that we're going to be able to extend. And that's a frame I'm going to use a lot, not just now when we're talking about multiplying polynomials, but later down the line in Modules 7 and 8 when we talk about factoring polynomials, we're going to be using the same reasoning, just going from the inside of the table to the out, instead of the outside of the table to the in, as we did here. Same tool, we can use it both backwards and forwards. So this is the first example of seeing it used forwards.